Hello and welcome. Before I start, I would thank you all for the great feedback which I got from you recently. All the tips, constructive critiques or simple thank you really made my day more than once. Meanwhile, the channel crossed the mark of 10,000 subscribers, and I'm really happy to see that so many people found some fun in my content. The amount of comments also increased a lot, and I assure you guys that even if I don't answer each one, I read all of them. So thank you very much. As I told in one of my videos some time ago, meanwhile, I even got some donations from the viewers, and today I would like to take a look into this huge box, which I got from a longtime viewer, Stibor from Slovakia. To torture me in excitement, he sent some photos, so I already know about some of the parts in advance. And the first box seems to be some kind of PCI Express card. But inside there is something else. It is a PCI USB 2 adapter. Actually a very useful part for any system with a PCI bus, and is very helpful if you want to transfer data to another PC using an USB stick or an external hard drive, for example. The next part is the Adaptec PCI SCSI controller, a very widely used controller for SCSI devices back in the days. Works perfectly even today because the drivers are very easy to find. And another SCSI controller, obviously from a compact OEM machine. It supports wide SCSI only, and it has a 64-bit PCI connector, which was usually used in servers back in the days. Okay, what's next? Here is Riva TNT2 Vanta 8MB AGP. This is a low-cost version of a TNT2, also known under the name TNT2 M64. It was produced with the memory interface reduced from 128 bits to 64 bits. This card outperformed the older Riva TNT while being less costly to produce, and still it was a lot slower than the real TNT2. They were quite popular in the OEM market, as most consumers simply assumed all TNT2 cards were the same, which obviously was not the case, but this is a very good card for testing of earlier AGP systems. And the next one is obviously another NVIDIA AGP graphics card, the GeForce FX 5200. This one was also widely used in the OEM market. Back then, ATI put NVIDIA under high pressure, releasing their Radeon 9500 and 9700 cards. They outperformed NVIDIA in every test by high margin and already supported DirectX 9 out of the box. At that time, NVIDIA had nothing comparable in the hand, so they introduced the infamous FX 5000 row of graphics cards, which weren't competitive to ATI at all, but at least they supported DirectX 9. The FX 5200 was the slowest of the series, but still got quite hot. And as you see, someone added a custom fan on top of the cooler to get the temperature down. This card was made by MSI and is in good visual condition. The capacitors don't seem to be blown, so I guess this is also a good card for testing purpose. The next one is some red mainboard. Oh, there is a small nut which probably fell from something off. So the mainboard seems to be equipped with Pentium 4 3 GHz with hyper-threading 848-Neo-V. Stibor was so friendly to include the ATX I/O shield with the board. Thank you very much for that. So yes, the board is an MSI 848P Neo-V. A nice red board with an AGP slot, where we could put the red MSI GeForce FX 5200 which we saw previously. That would make a nice all-red look to the system. The capacitors are all in outstanding visual condition, nothing is blown, the mainboard is very clean, also the CPU cooler looks very clean. As good as new, I would even say. This board seems also to support SATA and IDE, has sound and network on board. It could make a good base for a nice Pentium 4 retro build. Next one is a WinTV PCI TV tuner card. It's not usable for watching TV today anymore since the frequencies were turned down meanwhile, but this card can still be used for capturing video signal from home computers like C64, ZX Spectrum and others, since such cards have not only the tuner but often also composite and its video input. The next one is the M-Audio Audiophile 2496, a semi-professional sound card which delivers better audio quality compared to the most of gamers' sound cards from that time. I know that this card was used quite a lot by musicians back then. This connector was used for a harness which contained additional options for digital, analog as well as MIDI in and output. And here we have an ISA Super I/O controller with floppy IDE serial and parallel interfaces. I'm always glad to have another one of those. Here we have one from Gold Star Electronics and it was extremely widely used. On the back there are also jumper settings printed directly on the PCB. That is very helpful, but I think that the quality check sticker was placed very inconveniently and I will probably remove it later. Okay, the next part already looks very intriguing. There is just "work OK" written on it, but I have currently no idea what this could be. Okay, I guess I know what this is, but I never held something like this in my hands before, so I might be wrong. I think this is a standalone card which could be plugged into a server for its monitoring. As you see, this card has an own power plug, a VGA output, a PS2 keyboard and mouse port, and an RJ45 network port. This card is a computer for itself. It has a dedicated CPU, Intel i960, which is capable to run an embedded operation system, and it has an own graphics chip, ATI 3D Rage, with the 4 dedicated memory ICs around it. I think this card was plugged into a PCI slot of the server and connected internally to a special monitoring header on the mainboard. This way the server could be observed and controlled even if it was hanging or unpowered. This is very interesting part and I will have to take some time to learn more about it. Okay, what's next? 50-pin SCSI cable and another one. And another SCSI cable, this time for ultra-wide SCSI. The next is a PCI network card. It's an AMD network adapter, but the interesting thing about this one is that it has optical transceiver. Usual copper cables are limited in length because the signal strength decreases every next meter and some kind of amplifier, switch, hub, whatever has to be installed to keep up the signal quality. This can be worked around by using optical network cards like this one, which can be connected over hundreds of meters without any signal loss. And here is another one, so should I want to connect two computers over a longer distance, I would be able to take these nice network adapters. The next one is an ISA network adapter. Oops, seems that this one unfortunately didn't survive the trip. That is a shame, this is a nice network card, but the IC was ripped off the PCB completely with all the pads. So the repair is unfortunately not reasonable, otherwise this would be a nice card. Okay, the next one seems to be a CPU, UMC 486 DX3340. Rare. I bet it is, I never saw one in person. UMC green CPU U5S-Super 33/40. A little jump forward. This is what I found on Wikipedia about the CPU. The U5S version unfortunately has no FPU and is obviously comparable to the Intel 486SX. However, down here there is something interesting. Performance. The UMC U5 series design was focused on microcode optimizations. An equivalently clocked Intel or AMD processor required 40 cycles to perform an integer division, whereas the UMC processor required only 7, allowing the instruction to complete significantly faster. Performance is generally observed to be higher than competing processors on a clock-for-clock basis. The 40 MHz U5S model being comparable to an AMD AM486SX2 at 66 MHz with correctly configured motherboards. Sounds good to be true, isn't it? Well, this CPU was benchmarked at 33 MHz on the CPU Galaxy channel a while ago, and the results were really impressive. I'm very excited about it, and you will probably see this CPU in the one or another benchmark on my channel as well. Also interesting that due to an error in the microcode, Microsoft Windows 98 2nd edition identifies some processors as an Intel Pentium MMX, which could cause the operating system and software running with it to crash or exhibit undefined behavior. I'm really curious to find out more about it. And the next package is... I see, 287. Stibor told me about this one. And here you go, an Intel i287XL. The interesting fact about this one is that this IC is actually a 387 FPU, but Intel reproduced them as a drop-in replacement for the original 287 FPUs for the older systems. The real 287 coprocessors did usually run at lower clock than the CPU, but since this one is a newer but backported technology, it actually is able to run at the same clock as the main CPU and deliver the best FPU performance you can get on a 286. A very rare and expensive model, and I'm super happy to have it in my collection now. I will use it in my 286 machine, which can run the FPU with the same clock as the CPU. So, the next package has SIM72 on it. And yes, here we have a bunch of 72-pin RAM modules indeed. I actually have a lot of RAM, but I'm still glad about this package, since as far as I can see, most of these modules are FPM and they are harder to find than the Edo modules. And for the 486 builds, you need FPM only memory. Very nice. The next package has a VGA WDC written on it. This is probably a Western Digital ISO graphics card. And it is. I absolutely love them. In my opinion, this is one of the best ISO graphics cards out there. It is very fast and is highly compatible with everything you throw at it. Unfortunately, this card seems to have only 512 kilobytes of video memory, but do you remember all that memory modules? Well, I could get some memory ICs from there and transplant them onto this card and upgrade it to 1 megabyte for higher resolutions. However, for DOS gaming, these 512K are already absolutely sufficient. I'm super glad about this Western Digital card. Okay, and the next one is another ISO VGA card, now by UMC. Yeah, and this is a UMC indeed. This card is quite rare, but also quite slow, if I remember right. However, for a nice 286, it should be absolutely sufficient. The card has also 512 kilobytes, as far as I can see, but look at the jumper wires, probably for the memory configuration. That looks really funny. Anyway, I think that I will make some benchmarks with this card as well, since I only remember that it was slow, but I don't remember how slow. If you are interested, write into the comments if you want to see a video with some ISO VGA cards benchmarks in the future. Next, SDRAM. And indeed, some 100 and 133 MHz SDRAM modules from 32 to 256 megabytes. Next package says 3 times Pentium socket 370 1 GHz copper mine. Yep, 3 times 1 GHz CPUs. Another PCI ultra-wide SCSI controller with the BIOS ROM, so it can boot from the connected drives. And the same controller once again. Now I should have enough SCSI devices for the all projects I ever plan to do. An Isocom Industrial. Must be some kind of serial port adapter. I think this is not a serial port adapter. I would say that this is some kind of controller with proprietary interface for some machine or medical equipment. There are some jumpers for the IRQ and EEPROM and a microcontroller. The port looks like a usual serial port, but I think this is misleading. There is also an LED and some kind of push button. Well, I have no clue what this is, but if you know what this card could be, please write your ideas into the comments. And another try. Here we should have a PCI serial controller. Yes, and this is a serial port controller, as I know them from some industrial machines. It has 2 serial ports on the bracket for external devices and multiple internal headers. Such cards were pretty common in the telecommunication switching, computers and such things, and are really handy if you need a lot of serial ports. And we are diving deeper into this seemingly endless box of hardware and getting a 486 new battery plus need fix package. Let's see what's inside. Looks like a socket 3 486 mainboard indeed. It has a voltage regulator for 3 volts CPUs, 256 kilobytes of cache. It uses the wider SRAM ICs 4x64K. Many boards from the days had more common 8x32K SRAM ICs, but that have taken more space on the board, and on very late 486 boards such wider 64K ICs were used instead to cut the PCB costs. And on the back there is a jumper wire which goes to the keyboard controller. Well, all in all, it's a nice, very late PCI 486 mainboard, and maybe I will take care of it in one of my videos. And obviously another 486 mainboard. No post is written on it. Okay, another 486 PCI mainboard from about the same time as the previous one. Also, this board has a voltage regulator to support 3 volt CPUs. This board has a coin CR2032 battery which doesn't leak, so there is no damage from it. It also has an integrated IDE controller, 128K of cache. Everything looks clean and there is no obvious damage to see on the first glance. Also on the back, the board doesn't look to be damaged or heavily reworked. Well, I'll have to take a closer look at it later. Okay, next package is a mainboard again. This time it has to be a Super Socket 7 with some kind of keyboard error. Okay, a very nice and compact Super Socket 7 mainboard built around the famous VIA MVP3 chipset. I think that I have the same board in my to-be repaired box already. It is always good to have 2 of the same boards at hand to compare all kind of things during the repair. So it is great to have this one at hand. This board have seen some keyboard connector rework, but as the description on the package have said, that didn't help, I guess. In this donation there are so many mainboards, maybe I should make a repairathon once again. Last time many of you seemed to have a lot of fun with it, so why not? Okay, what's next? ALS 4000 PCI sound card. A pretty simple sound card, but if I remember right, this one does work in DOS. But I'm not quite sure about that. Next one is an ISA LPT port. However, this is actually a SCSI ISA controller, which was used for external SCSI devices like scanners and CD-ROMs back in the days. And here we have a Sound Blaster CT4170 ISA sound card. Yeah, I know this card pretty well. It is also called Sound Blaster 16 Vibra and is very late Creative Sound Blaster 16 sound card. The sound card was highly cost reduced and has no Yamaha OPL3 FM synthesizer anymore. It was replaced by Creative's own CQM implementation, which sounds very odd in the old DOS games. On the good side, however, this card has a clean sound and a very good compatibility. It usually just works, and if you don't mind to have the odd FM sound, this card is a good option. And another ISO sound card, now with a ALS 120 chipset. This is also a really uncomplicated sound card, which emulates Sound Blaster Pro and Sound Blaster 16 both in stereo. That was absolutely not common for the sound cards back then. Not even Creative's own Sound Blaster 16 could do Sound Blaster Pro in stereo, and all the clones could only Sound Blaster Pro, but not 16. On the bad side is, however, again the custom OPL3 implementation, which sounds quite different from the original Yamaha sound, but it has a wavetable header for an additional add-on cards and general MIDI support. The audio quality on these cards is, however, usually mediocre. Still a high compatible and reliable sound card for a simple retro PC. And another Creative Sound Blaster 16 Value, model CT2770. Yeah, this is one of the earlier models of the cost-reduced Sound Blaster 16 Value series. On the good side is obviously the good compatibility, and unlike the later 16 Value revisions, this one has still the original Yamaha OPL3 synthesizer integrated into the chipset. Here you can see this OPL inscription. Unfortunately, all the later revisions, like the CT4170, which I showed before, replaced it by the CQM chip and didn't sound right in the older games anymore. On the bad side, compared to the first generation of the Sound Blaster 16, was the reduced audio quality, missing wavetable header, and the notorious hanging note bug, when using external MIDI devices like the MT32, for example. This card has some botch wires on the back, but I will have to check out later what they are exactly for. Boy, oh boy, this box seems to be really endless. Stibor obviously sent me hardware which would be enough to fill 3 channels with content for the next 3 years. And the next package says Industrial Socket 7 works, supports K6 500, K6-2, voltage auto. Let's see. So, this board already seems to have some Intel Pentium MMX CPU in it. What's this? A Pentium MMX 200. Okay, the board has a Dallas 12887 RTC module. If it's empty, luckily I have a good replacement. The board is a Mostron P55A-4 revision 142. The chipset is ALI M1543 M1541. It was a very successful chipset for the Super Socket 7 mainboard. It was also known under the name Aladdin 5 and was made by Acer Labs. It supported frontside bus of up to 100 MHz and important AGP, which was a standing out point of the Super Socket 7 mainboards. However, this board seems not to have an AGP slot at all. Only 3 normal PCI slots and another strange PCI with an offset to the others. I have no clue what this is used for, and I never saw something like this before. Usually I would expect an AGP slot here on a normal Super Socket 7 board, but this board doesn't seem to be normal. If you know more about this slot, please enlighten me in the comments. Other than that, this board looks like a normal Super Socket 7 mainboard, and I will definitely try it out soon. Oh, wow, we finally reached the bottom of the box. I already stopped to believe that there is a bottom at all. This is another mainboard. Oh yes, the note says not tested, no battery. And here, future 286 12 MHz plus RAM, controller on board, rare. Yes, I remember Stibor sent me some pictures of this board, so let's see what we have. Wow, a great looking 286 mainboard, already equipped with some memory. The CPU is an AMD 286 12 MHz, and the crystal oscillator here in the corner confirms it with 24 MHz, which are divided by 2, feeding the CPU with 12 MHz eventually. The math coprocessor socket is empty, and in the future I could use that 287XL FPU here, which Tibor put into this donation as well. As I mentioned, this board has already the SIM memory populated. It seems to have 4 × 1 MB SIM modules, which would mean an incredible amount of 4 MB of memory. That's huge for a 286, but that's not everything. Look at those ICs down here. Each one is 128K and there are 8 of them, which brings the total memory size to a whopping 5 MB. And here on the side, those 4 ICs are probably the parity chips. This memory configuration would cost quite a lot in the end of 80s. Almost nobody had so much RAM in the PCs back in the days. This mainboard has some damage from a leaky battery, so there is definitely some work to do. Well, for this video I was planning to take a closer look at least on some parts in this donation, but it is so huge that it took much more time just to take a brief look at it. I will need a lot of time to get through all the hardware to check it and repair if needed, but I would say since this was the last and the oldest mainboard in this box, I would like to take care of this one first, so join me in the next part if you want to see if this mainboard is working at all. With the corrosion there is definitely some work to be done anyway, but we will see if it hides even more surprises. I would really like to thank Tibor once again for this amazing pile of hardware. This will give a lot of material and ideas for the videos in the future, and even if I will not be able to make a video about every one of those parts, you definitely will see the one or another used in my retro builds or repairs. Once again, the first of such videos will follow soon, so keep an eye on the releases. Please write into the comments what you would like to see from these parts in the future, or if you have some information on some of this hardware which could help me to make such videos. And so far, thank you and goodbye.